Walk through an Amish garden in midsummer and something is immediately wrong. Not with the garden, with your expectations. The tomato plants are dark green to the top. The squash leaves are clean and flat. No yellowing at the edges, no powdery residue, no curled tips that signal something feeding underneath. You look for the damage that every other garden in the county is dealing with, and it is simply not there. This is not luck. It is not better soil by accident. And it is not a secret they are keeping. Ask an Amish gardener what they spray and they will tell you immediately. Nettles, soaked in water for 2 weeks and poured directly onto the soil around every plant in the garden, once a week from spring until the first frost. That is the entire method. A weed that grows for free on every continent, water, and time. A German agronomist named Julius Hensel documented the mechanism behind this in 1894. His findings were published, distributed across Europe, adopted by thousands of small farms, and then systematically ignored once the synthetic fertilizer industry established its commercial dominance in the early 20th century. His book went out of print in every major language within 2 decades of the Haber-Bosch process reaching commercial scale. It was not banned. It was simply made economically irrelevant. Here is what Nettle water actually does to soil, why it works faster than anything in a bottle, and why a weed you have probably cursed at is the most complete plant tonic ever documented. What nettles are actually made of. Stinging nettle, Urtica dioica, is not a garden pest. It is a hyperaccumulator. That is a specific botanical classification for plants that pull minerals from deep soil layers and concentrate them in their above-ground tissue at levels far exceeding what is present in surrounding vegetation. A dry weight analysis of stinging nettle tissue reads, like the label on a premium fertilizer bottle, nitrogen at 2.5 to 5%, potassium, magnesium, calcium, iron, silica, and manganese in concentrations that most cultivated vegetables cannot match even at peak growth. The plant spent its entire life mining the subsoil for these compounds. When you cut it, soak it in water, and pour that water onto your garden, you are not adding a supplement. You are returning concentrated mineral wealth from 3 feet underground directly to the root zone of your plants. This is what Julius Hensel understood in 1894. He called it returning what the soil had lost, not from a bag manufactured in a factory, from the plants that had been pulling it upward for free the entire time. The fermentation step and why it matters. Fresh nettle water delivers minerals. Fermented nettle water delivers something more significant. When cut nettles sit submerged in water for 10 to 14 days at room temperature, the naturally occurring bacteria on the plant surface begin breaking down the cellular structure. The process is identical in principle to the rice water fermentation documented in Korean natural farming. The bacterial population multiplies, the cell walls of the nettle tissue rupture, minerals bound inside plant cells become freely soluble. Compounds that were locked in organic form convert into ions that plant roots can absorb directly without any further biological processing. The liquid darkens. By day 14, it is the color of strong tea and smells aggressively of ammonia. That smell is not decay. It is nitrogen converting into a plant-available form. The same transformation that the Haber-Bosch process performs industrially at high temperature and pressure is happening in a bucket in an Amish garden at room temperature over 2 weeks, using nothing but bacteria and time. A 2016 study published in the journal Biological Agriculture and Horticulture measured the nutrient content of fermented nettle water at various stages of decomposition. By day 14, available nitrogen had increased 340% compared to the fresh liquid. Potassium had doubled. The microbial population in the liquid had reached concentrations comparable to commercially produced compost tea. This is not folk wisdom dressed up with science after the fact. The chemistry was always there. The Amish were simply the ones still paying attention to it. What it does to the soil. Here is where the method separates itself from every liquid fertilizer on a garden center shelf. Synthetic liquid fertilizers deliver soluble nutrients directly to roots. The plant absorbs what it needs, the excess leaches into groundwater, and the soil biology is unchanged. Next week, the levels drop back to baseline and you apply again. The system requires you to keep showing up with a bottle. Fermented nettle water does something structurally different. The dense microbial population carried in the liquid colonizes the soil around the root zone. Those organisms establish, reproduce, and begin doing what soil microbes do, breaking down organic matter, freeing locked minerals, building the fungal networks that extend root access. A single application changes the biological composition of the soil. That change persists and compounds. Additionally, the silica content of nettles is exceptionally high. Silica is not typically listed on fertilizer labels because it cannot be patented and it does not produce the immediate visible growth response that nitrogen does. But silica is what builds cell walls. Thick, rigid cell walls are the primary physical barrier against fungal infection, bacterial disease, and the mouthparts of sucking insects. A plant with sufficient silica is structurally harder to damage. Aphids struggle to penetrate the leaf surface. Fungal spores cannot establish as easily. The plant is not fighting disease. It is built in a way that makes infection difficult from the start. This is exactly what John Kemp documented on his Ohio farm and confirmed across 4 million acres. Mineral balance produces structural plant health that pests and pathogens cannot easily overcome. Nettles deliver that mineral balance in a form the soil can use immediately. How to make it? The method requires 3 things: fresh or dried nettles, a container that holds water, and patience. Fill a bucket or barrel loosely with chopped nettle leaves and stems. Do not pack them tightly. You need water to circulate through the plant material. Cover with water completely, enough that nothing is exposed to air at the surface. Weigh the plant material down with a stone or small board if needed. Cover the container with a loose lid or cloth to keep debris out while allowing gas to escape. Fermentation produces carbon dioxide and the container needs to breathe. Leave it for 10 to 14 days. Stir once daily if possible. In warm weather, the process accelerates and 10 days is typically sufficient. In cool weather, allow the full 2 weeks. The liquid is ready when it has turned dark brown and the plant material has largely broken down into a soft, structureless mass. Before applying, dilute the finished liquid at a ratio of 1 part nettle water to 10 parts clean water. This is not optional. Undiluted fermented nettle water is acidic and nitrogen concentrated enough to burn roots and suppress the same soil biology you are trying to build. Diluted, it delivers a precise inoculation at a strength the root zone can handle immediately. Apply directly to the soil at the base of each plant, not on the leaves, once per week throughout the growing season. In the first 2 to 3 weeks, you will typically see a visible deepening of leaf color as available nitrogen increases in the root zone. By midsummer, in a garden receiving weekly applications since spring, the difference in plant structure compared to an untreated bed is visible from the end of the row. The spent nettle material left in the bucket after straining is not waste. Work it directly into your compost or dig it into the soil around established plants. It continues decomposing and releasing minerals for weeks. Why this stays in Amish gardens and nowhere else. The global crop protection market is worth $84 billion annually. The plant nutrition market adds another $185 billion. Both depend on the same fundamental premise that your garden cannot feed and protect itself without purchased inputs applied repeatedly every single season. A bucket of nettles harvested from the edge of your property, fermented for 2 weeks, and diluted into 10 liters of water costs nothing. It improves the soil biology permanently with each application. It delivers silica that builds structural pest resistance the way no spray can replicate. And it has been running quietly in Amish gardens for generations, while the industry built around the problem it solves grew into a $250 billion market. Julius Hensel's book went out of print. The mechanism he documented did not change. The nettles along your fence line are still pulling minerals from 3 feet underground, still concentrating them in their tissue, still waiting to be cut and soaked and returned to the soil where your plants actually need them. The Amish did not discover this. They simply never stopped doing it.